Hello my friends and welcome back to the Today Machine channel. Teamwork is essential in achieving complex engineering and industrial projects. It allows diverse experts, engineers, technicians, and operators to combine their skills, knowledge, and experience to solve challenges efficiently. At Coffler, teamwork is the cornerstone of every successful project. In a recent machinery installation, the team demonstrated seamless collaboration, coordinating between engineers, technicians, and logistics specialists. Effective collaboration ensures tasks are coordinated, deadlines are met, and safety protocols are maintained. Safety protocols were strictly followed, ensuring both personnel and equipment protection. By leveraging collective skills and experience, the team completed the installation efficiently and accurately. This example highlights Coffler's commitment to professional collaboration, precision, and delivering high-quality outcomes through effective teamwork. Operating a 50-foot lathe is a true feat of engineering and skill. This enormous machine, with its 50-foot bed, 12-foot swing, and 10-foot diameter 4-jaw chuck, is built to handle some of the largest industrial components in the world. Here, a 9,000 HP motor armature commutator is being machined, a critical part once used to shred automobiles, requiring absolute precision. The lathe also shapes stationary runners for dewatering pumps at Pearl Harbor, brassware rings, and massive 10-foot generator armatures. Every cut, feed, and rotation is carefully monitored for alignment, tool wear, and vibration. Operators combine experience with meticulous attention to detail to ensure each component meets stringent industrial standards. This machine makes the impossible possible, turning raw materials into critical, oversized components for high-power machinery. Maintenance was performed on a dewatering pump impeller used in a submarine dry dock at Pearl Harbor, focusing on dynamic balancing to ensure optimal performance. The process began with an initial baseline analysis to assess the existing imbalance and determine corrective requirements. Temporary calibration weights were added strategically to simulate adjustments and refine the balancing approach. Following this, permanent metal balance weights were installed at precise locations on the impeller. Multiple measurements were taken throughout the procedure, with both weight placement and mass adjusted iteratively to achieve the desired balance. Comparison of before and after results confirmed a significant reduction in vibration and rotational irregularities. This careful balancing process extends the operational lifespan of the impeller, enhances pump efficiency, and reduces stress on the shaft and bearings, ensuring reliable dewatering operations in critical submarine dock applications. A 60-ton generator was transported for repair using a 9-axle heavy-duty truck trailer designed to handle such extreme loads. Due to its size and weight, unloading required careful disassembly. The rotor was separated from the stator to facilitate safe handling. 2 cranes were precisely coordinated to lift and maneuver the rotor, ensuring stability and avoiding structural damage. The rotor was then transported to a designated temporary storage area, where it awaited further inspection and maintenance. Throughout the operation, engineers monitored load distribution, crane angles, and lifting points to maintain safety and efficiency, demonstrating meticulous planning for moving heavy electrical machinery. Highlights the professional motor rewinding and rebuilding process at Coffler Electrical in San Leandro, California. Skilled technicians begin by carefully inspecting each electric motor to identify faults, worn components, or signs of overheating. After the evaluation, the motor is fully disassembled so every part can be cleaned, tested, and restored. The rewinding stage involves removing old coil windings, preparing the stator core, and installing new windings with precision to ensure proper insulation and long-term performance. Once the coils are secured and tested, the motor is reassembled with attention to alignment and balance. Technicians then perform rigorous testing procedures, checking voltage, rotation, vibration, and efficiency to confirm that the rebuilt motor meets or exceeds original specifications. Throughout the process, Coffler Electrical focuses on reliability, safety, and workmanship, ensuring each motor operates smoothly and efficiently after service. This commitment to quality makes their services a trusted solution for industries that depend on durable, high-performance motors operating under demanding conditions daily. The BAP Pisco multi-purpose vessel marks a significant milestone for CIMA Peru. The first stage of construction, from keel laying to launch, has been successfully completed, reflecting the coordinated efforts of design, planning, and production teams. Steel processing and module fabrication occurred across multiple workshops, including naval construction, piping, valves, and painting. Each department contributed specialized expertise, ensuring structural integrity, system integration, and finish quality. Assembly followed a modular block method, with individual sections precisely aligned and welded to form the hull and superstructure. Interior systems, including electrical, plumbing, and HVAC, were installed concurrently to maximize efficiency. Rigorous quality control and inspection protocols were applied throughout, guaranteeing compliance with naval standards. During the launch, the completed vessel was carefully floated and stabilized, demonstrating the precision of block alignment and structural assembly. This process involved coordinated use of cranes, hoists, and temporary supports, highlighting the technical complexity of shipyard operations. The project emphasizes teamwork, engineering skill, and advanced shipbuilding techniques, culminating in a fully operational vessel ready for service with the Peruvian Navy. The launch ceremony celebrated both technical achievement and the dedication of the CIMA workforce. The construction of the sail training ship BAP Union by CIMA Peru represents a landmark achievement in Peruvian naval shipbuilding. Conceived as a modern bark-rigged vessel for cadet training and international representation, BAP Union was designed to combine historical sailing traditions with contemporary maritime engineering standards. The project is executed entirely at CIMA's shipyard in Callao, where precision planning, advanced machinery, and skilled labor converge to bring the ship from design to launch. The hull is built using a modular block construction method, dividing the vessel into 38 prefabricated steel blocks. This scene 29 modules have been completed, corresponding to crew accommodation, engineering spaces, and the double bottom. An additional 9 blocks are in the process of construction and assembly, including the aft section and central deck blocks. Module assembly begins with precise alignment and positioning in the shipyard. Cranes and hydraulic gantries lift each block into place, while laser-guided measurement systems ensure exact positioning. Blocks are temporarily supported on adjustable brackets, while skilled welders connect primary seams using CNC-assisted and manual welding techniques. Internal systems such as piping, electrical wiring, and ventilation ducts are pre-installed in the blocks and integrated during assembly to ensure seamless continuity. Once the blocks are welded together, interior and machinery installations are completed. Approximately 70% of the engine room equipment, including main engines, auxiliary generators, and climate control units, has already been installed in the prefabricated modules. Hoists and modular scaffolding facilitate the installation of heavy components, while technicians verify alignment and functionality before final welding. Modular assembly allows simultaneous work on multiple sections, reducing overall construction time and ensuring high precision. Masts and rigging are engineered for both structural strength and sail performance. The four-masted bark design comprises approximately 400 square meters of sail area, with masts manufactured from steel, reinforced with laminated wood. Each mast undergoes rigorous load and deflection testing before installation. Hoisting systems, block sheaves, and standing rigging are prefabricated and adjusted in a controlled environment to ensure proper tension and alignment. Interior compartments are constructed using CNC milled panels and furniture, providing living quarters, classrooms, and operational spaces for cadets and officers. Integration of HVAC, potable water, and sewage systems is carried out concurrently, with interior finishing to maintain workflow efficiency. Throughout the project, SEMA employs 3D laser scanning, photogrammetry, and digital modeling to monitor alignment and dimensional accuracy. Each block and component is checked against design specifications, with quality control teams documenting material certificates, weld inspections, and structural verifications. The final assembly in the dry dock involves lifting and welding all modules into their permanent positions, aligning hull plating, decks, and bulkheads. Electrical, mechanical, and piping systems are connected across modules, creating a fully integrated vessel ready for trials. Sea trials will test performance, stability, and maneuverability under sail and power, validating the vessel's operational capabilities. BAP Union measures approximately 115.5 meters in length, displaces 200 tons, and carries up to 257 personnel with a maximum speed of 12 knots. The launch and christening of the sail training ship are scheduled for the end of this year, marking the culmination of years of design, fabrication, and assembly work. BAP Union will serve as a floating training academy and ambassador of Peru, providing cadets with hands-on seamanship experience while representing national maritime heritage abroad. The project illustrates the integration of traditional shipbuilding craftsmanship with modern engineering, advanced machinery, and precise planning, demonstrating SEMA Peru's capacity to deliver world-class naval vessels. This achievement strengthens Peru's naval training infrastructure and highlights SEMA's industrial and technological capabilities, combining modular construction, CNC precision, automated welding, advanced material testing, and state-of-the-art systems integration in a single iconic training ship. At the heart of Europe's railway infrastructure lies a cutting-edge, concrete sleeper production plant, engineered by Vollert Anlagenbau for Leonhard Moll. Since Leonhard Moll patented the pre-stressed concrete sleeper in 1937, his Bettenwerk operation has produced tens of millions of these durable rail components across multiple sites. The production line begins with raw concrete mixing. Leonhard Moll's modern facility utilizes IRIC-intensive mixers, installed as part of a Vollert design system, to create very dry, high-strength mixes with excellent homogeneity. Aggregates, cement, and reinforcement components are fed via twin-belt elevators and silos to precisely the right proportions. Vollert's plant concept emphasizes efficient material flow without deep foundations, even under difficult soil conditions. Once the concrete is mixed, it's transferred into a fully automated mold circulation system. Vollert's turnkey plant features a mold circuit that continuously cycles multiple sleeper molds, optimizing the productivity of the line. The molds fill with pre-stressed concrete and are demolded after a controlled early stripping process. Vollert's advanced formwork solutions manage the high-speed circulation, reducing idle times. After demolding, the newly cast sleepers pass through a pre-stressing station where high-tension steel wires embedded in each sleeper are tensioned with hydraulic jacks. This gives the sleepers their characteristic strength and longevity. Once pre-stressed, the elements move to curing or storage areas. Quality control is fully integrated. Vollert's system includes automated measurement and testing points where sleeper geometry, reinforcement placement, and surface finish are verified. Leonhard Moll ensures all products comply with DIN EN 13230 standards and railway operator specifications. The plant also supports the production of special sleeper designs, from eco-friendly grass track modules to 3-rail and twin sleeper systems, all made to custom specifications using the same fully automated workflow. Steered by an integrated control system, logistics are optimized for minimal manual handling and high throughput. The automation, combined with Leonhard Moll's technical heritage, results in a world-class sleeper production facility that delivers consistent, high-quality concrete sleepers for rail networks across Europe. This partnership between Leonhard Moll and Vollert Anlagenbau exemplifies how modern precast technology, industrial automation, and process engineering come together to support rail infrastructure in a scalable, efficient, and reliable way. MST bar is a high-performance fiberglass structural reinforcing bar engineered for advanced concrete reinforcement. Manufactured from continuous glass fiber-reinforced polymer strands, it features an integrated rib profile that maximizes mechanical interlock with concrete, providing a bond superior to steel or conventional glass fiber-reinforced polymer. The bar is non-corrosive, non-conductive, and 75% lighter than steel, enabling easier handling, cutting, and installation on site without sparks or debris. Pre-bent configurations are available for precise corner and junction placement. Its combination of tensile strength, rupture resistance, and dimensional stability ensures long-term durability and reliable structural performance in harsh environments. In 2019, Lietuvos Geležinkeliai completed maintenance and modernization on 83 kilometers of railway as part of a 2,000-kilometer national network. From 2014 to 2024, 640 kilometers of track, nearly one-third of the network, are scheduled for replacement, with a total investment of €247 million. Upgrades involve high-precision track-laying machines, ballast tampers, and automated welding units to ensure exact rail alignment and continuity. Modern track inspection systems detect wear, defects, and contact line issues, allowing immediate corrective action. Specialized overhead line equipment performs automated tensioning and alignment to reduce failures. Annual investments of €40 million support the replacement of approximately 80 kilometers of track each year. Engineering teams coordinate on-site with GPS-guided machinery and mechanized switch installation systems, minimizing speed restrictions and downtime. These technical measures reduce contact network faults, optimize track geometry, and enhance overall operational reliability, ensuring Lithuania's railway infrastructure meets international safety and performance standards. Etihad Rail has completed excavation of the GCC's longest rail tunnel, a 1.8 kilometers passage through the Hajar Mountains. Built under challenging geological conditions, the tunnel used advanced technology and techniques to ensure stability. It is the longest of 9 tunnels in Package D of the UAE National Rail Network. In 2022, Composite Tech showcased its advanced manufacturing equipment for glass fiber reinforced polymer production, including rebar, mesh, and bent elements. Their Cort 4 and CT6 production lines enable continuous pultrusion of multi-strand GFRP rebar, delivering high-volume output while maintaining precise rib geometry and resin distribution. For mesh, the CT2M line produces fiberglass grid reinforcement with customizable cell sizes and automated resin application. Their equipment for bent elements, such as stirrups and hooks, uses CNC-controlled bending technology that preserves fiber integrity while forming precise shapes. All systems are highly automated, energy efficient. Composite Tech produces GFRP reinforcement mesh using advanced machinery, delivering superior rupture, breaking, and tensile strength. Engineered for durability and reliability, this GFRP rebar meets the rigorous demands of professional construction projects worldwide, providing enhanced performance and long-lasting structural reinforcement. Fiberglass reinforcing bar is a composite material engineered for demanding construction applications. Its high tensile strength, corrosion resistance, and lightweight properties make it suitable for replacing steel reinforcement in highways, bridges, airports, docks, stations, water conservancy projects, and underground structures. Optimal performance requires strict adherence to quality control during manufacturing, handling, and installation. Composite Tech has achieved a new production milestone by manufacturing 6 glass fiber reinforced polymer reinforcing bars simultaneously. This advanced process uses high-precision pultrusion machinery that ensures uniform fiber alignment, consistent resin impregnation, and controlled curing. Each bar achieves enhanced mechanical properties, including superior tensile strength, rupture strength, and bending resistance. The multi-bar production system increases output efficiency while maintaining strict quality standards. Automated monitoring controls temperature, pulling speed, and resin flow to guarantee consistent cross-sectional dimensions and optimal bonding characteristics. This breakthrough demonstrates the capability of modern GFRP manufacturing equipment to meet growing global demands for lightweight, corrosion-resistant, and high-performance construction reinforcement. Number 78,018. A British Railways Standard Class II locomotive built at Darlington in 1953 operates live steam excursions on the Great Central Railway. On its return journey from Leicester, it reverses to pull passenger carriages along the scenic Quorn to Loughborough section, offering rail enthusiasts a classic steam experience with authentic operational procedures and historical charm. The Slipersbeter RBS combined with a Knox tilt rotator creates a highly efficient railway maintenance tool. The Slipersbeter attachment, designed to change sleepers, works seamlessly with the tilt rotator to allow for precise positioning and variable depth control. Using the Knox unit, the attachment can rotate 360 degrees, while tilting up to 50 degrees, converting the carrier machine into a fully articulated work platform. The Knox tilt rotator offers tilt angles ranging from 2 by 45 to 2 by 55 degrees depending on the model, and continuous 360-degree rotation, providing maximum flexibility for complex operations. Its compact design eliminates protruding cylinders, reducing the risk of damage and minimizing maintenance requirements. For increased versatility, the tilt rotator can be equipped with a gripping cassette and a control system tailored to both the machine and the operator. This integration ensures smooth, responsive handling, allowing operators to perform precise movements in confined spaces. Whether used for material placement, excavation, or detailed site work, the combination of the Slipersbeter and Knox tilt rotator enhances productivity, safety, and operational efficiency on modern construction sites. The URM 700-2 by Placer and Thierer is a versatile machine designed for efficient ballast cleaning on railways. Its compact construction requires only an 8-meter work gap, enabling operations without full track closures. At the front, the machine removes material from the track shoulder, while the infinitely adjustable excavating sword ensures precise material extraction across varying widths. Trough scrapers collect the excavated ballast and transport it to conveyor and hopper units. Simultaneously, track lifting and holding devices maintain alignment, while front ballasting and tamping zones stabilize the track. Cleaned ballast passes through a vibrating screening unit, separating reusable material from spoil. New ballast is inserted via the conveyor and hopper system, achieving uniform distribution across the full ballast bed width. This integration of excavation, cleaning, and redistribution ensures minimal downtime, cost-effective maintenance, and thorough track stabilization, making the URM 700-2 an indispensable solution for modern railway upkeep. The Sombrio Bridge, located on Highway 14 near Port Renfrew, was upgraded from a single-lane timber structure to a modern two-lane bridge spanning 124 meters, integrated into a new 1.2-kilometer highway alignment designed for 70 kilometers per hour. The lanes are 3.6 meters wide, with 1.5 meter paved shoulders on each side. Construction began with pier foundations, the south abutment, and north retaining walls, followed by formwork installation for the south abutment. Retaining walls were completed, and girders were launched across the span. Deck panels were then positioned and reinforced with stainless steel rebar, with deck screed test runs ensuring proper alignment and leveling. Concrete was placed for the deck, cured, and insulated to control temperature during hardening. Approach slabs and pier deck sections were installed next. The parapet forms were set, reinforced, and concrete was poured to complete the bridge structure, providing a durable and modern crossing for Highway 14. LTG Infra oversees Lithuania's railway infrastructure, ensuring maintenance and safety. After several years, a snowplow train returned to operation due to heavy snowfall. The 180-ton train, consisting of a lead engine, 2 intermediate wagons, and a rear wagon, is operated by 3 qualified engineers. It collects up to 350 cubic meters of snow, clearing tracks and access roads efficiently.